Welcome to this explainer. Today, we're diving into something absolutely crucial, the NIST AI Risk Management Framework 1.0. We are going to figure out how to build and deploy artificial intelligence that we can actually trust. We all know AI is fundamentally reshaping our world. It's driving wild scientific breakthroughs and economic growth. But let's be real, it also carries enormous, totally unprecedented risks. The National Institute of Standards and Technology, or NIST, recognized this and put together a really comprehensive blueprint to help organizations navigate these turbulent waters. Here's our agenda for today. We're going to cover AI's unique risk landscape, define trustworthy AI, look at the AI RMF core, explore govern as the cultural foundation, walk through the map, measure, and manage loop, and finally discuss our collective responsibility. All right, let's jump right into Section 1, AI's unique risk landscape. We have to ask ourselves a crucial question right out of the gate. Why is AI risk fundamentally different from traditional software? Honestly, assuming AI is just another software program is the first major trap you can fall into. If you treat a complex generative AI model the same way you treat a basic spreadsheet app, you are leaving your entire organization and society completely exposed. Think about it. Traditional software is pretty static and predictable, right? It follows clear coding rules. But AI systems, entirely different beasts. They evolve. Their training data drifts over time, meaning a system that was highly accurate yesterday might behave totally differently a month from now. They are also incredibly inscrutable. Sometimes even the developers themselves don't fully understand how the model arrived at a specific decision. And most importantly, AI systems are inherently socio-technical. That means they interact with human behavior and society in super complex, unpredictable ways. When a traditional app crashes, what happens? You might lose an hour of work. Annoying, sure. But when an AI goes wrong, the harm cascades across three really severe levels. First, you've got harm to people. We're talking devastating impacts on civil liberties, physical safety, and real damage to vulnerable communities. Second, harm to an organization, like total reputational ruin or massive security breaches. And finally, harm to an entire ecosystem. A runaway algorithm could literally trigger a collapse in the global financial system or cause massive environmental damage. The stakes are wild. Which brings us to Section 2, defining trustworthy AI. So, we know the risks are terrifying, but what does a good, trustworthy AI system actually look like? Well, trust has a strict hierarchy. Valid and reliable is your absolute mandatory bedrock. If the system doesn't consistently do what it's supposed to do, literally nothing else matters. But wrapping entirely around that foundation is accountable and transparent. You simply have to have visibility into the system across its entire lifecycle to verify any of this. Building on that bedrock, we have the core characteristics of trust. Every single one of these is vital. A system must be safe, meaning it protects human life and property. It's got to be secure and resilient, so it can withstand attacks or unexpected shifts. It needs to be explainable and interpretable, so it can actually make sense of its outputs. It must be privacy enhanced to protect human autonomy. And finally, it absolutely has to be fair, meaning we're actively managing computational and human biases. But here is where it gets tricky. You can't just max out every single trait. It's a massive balancing act. Sometimes, if you implement really strict privacy enhancements, or if you force a system to be completely explainable, you might actually lower its raw predictive accuracy. Trustworthiness isn't a simple checklist. It is a continuous series of trade-offs that require human judgment based on exactly where and how the AI will be used. Okay, Section 3, the AI RMF core. So how do we balance those complex trade-offs? Let's look at the solution from NIST. There's a quote from the framework that hits the nail on the head. Understanding and managing the risks of AI systems will help to enhance trustworthiness and, in turn, cultivate public trust. That is our ultimate objective right there. Risk management is not just about avoiding disaster or checking a compliance box. It's the active mechanism for building public trust. If society doesn't trust AI, the technology is never going to reach its full potential. At the very heart of this explainer is the AI Risk Management Framework core. It operates as a continuous, iterative loop made up of three functions: map, measure, and manage. And notice how they all constantly revolve around a central hub called govern. You don't just do this once and walk away. This is a living cycle that continues for as long as the AI system lives. Let's zoom in on that center. Section 4, govern, the cultural foundation. We literally have to start here, because without the right organizational culture, the rest of the framework completely collapses. Simply put, govern is your human accountability structure. You could have the best testing metrics in the world, but if your leadership doesn't prioritize risk management, it won't matter. Governing ensures that executive leadership takes direct responsibility. It aligns the highly technical side of AI with the organization's core values, and it forces diverse teams to think critically about potential impacts before a single line of code is even written. Governance also dictates your organization's ultimate risk tolerance. It sets strict policies for things like third-party data supply chains, because, hey, you're responsible for the data you feed your model, even if you bought it from someone else. Ultimately, a strong governance structure empowers teams to make those incredibly tough go or no-go decisions. They need the authority to pull the plug on an AI system before it goes live if it proves too risky. Moving right along to Section 5, Map, Measure, and Manage. With our governance foundation locked in, we can explore that operational loop. Think of these 3 steps as your continuous engine. First, you map. Figure out the context of your AI and identify what could go wrong. Second, you measure. Rigorously test the system against those specific risks. And third, you manage. Prioritize and actually fix the biggest issues based on their real-world impact. Mapping is all about preventing nasty surprises. You are anticipating how this model will behave in the messy real world, not just in a pristine laboratory. Who is going to use it? How might it be misused? What are the absolute limits of its knowledge? And what happens to society if it operates beyond those limits? If you don't effectively map the context here, you're going to end up measuring the wrong things in the next phase. Once mapped, we measure. And guys, this goes way beyond basic code debugging. We are talking about applying rigorous, scientific testing to track highly complex metrics. You evaluate the system against all those trustworthy characteristics we looked at earlier: fairness, privacy, security. And crucially, because AI evolves, you have to track emergent risks over time. You need constant feedback loops to verify that your measurements are actually catching real-world problems. Then, as we shift to the manage function, we have to swallow a hard truth. A zero-risk AI system simply does not exist. We call this residual risk. Trying to eliminate 100% of the risk from a complex AI is virtually impossible. So managing is about prioritizing our responses. You mitigate what you can, and you meticulously document the residual risk that's left over so that the people and communities actually using the system know exactly what they are interacting with. Which brings us to Section 6, our collective AI responsibility. We know the blueprint, but whose job is it to actually pull this off? Managing AI risk isn't just something a coder does alone in a server room. It spans incredibly diverse dimensions. Across the entire lifecycle, from collecting data to daily operations, everything orbits around people and planet. And that means you need totally different experts at every single stage. Effectively mapping, measuring, and managing AI has to be a democratized effort. Yes, obviously we need brilliant AI developers and designers, but we equally need system integrators, C-suite executives on oversight boards, and independent impact assessors. Most importantly, we absolutely have to include the people and planet dimension, pulling in sociocultural analysts, legal experts, and the actual everyday communities who are going to be directly impacted by these systems. So, as we wrap up this explainer, I want to leave you with one final thought to chew on. AI is reshaping our reality at breakneck speed. Will we choose to build AI systems that merely function, maximizing pure performance while leaving society to deal with the fallout? Or are we going to commit to the rigorous, structured, and continuous hard work required by frameworks like NIST to build systems we can genuinely trust? The blueprint is right in front of us. What we do with it is entirely up to us.